do, do, do. 1, 2, 3. 1, 2, 3. Are you ready to do triangles with me? All right. Hey, people, guess what? I am back. Hey, that's 3 words. I am back. Woo-hoo-hoo. Hey, we're talking about triangles today. We're going to talk about how to do this stuff with 3 sides, so let's get right into it, okay? So, let's talk about how to classify them first, all right? So you can classify triangles in 2 ways, okay? So you can classify by side and by angles, okay? So I'm going to make a little T-chart here. If you'll make this little T-chart with me, we'll talk about how to do it by sides and angles. Okay, so let's talk about sides first. Okay, so we got 3 ways there. 1, 2, 3. Also got 3 ways to do angles too. So you can go and pick one choice out of the side column, one choice out of the angle column. All right, when you classify them. So let's see what we got sidewise. If it's got all 3 sides are the same, okay, or all 3 sides are congruent. Anybody know what that word is? If all 3 sides are congruent, that would be known as the old equilateral. That means all sides and all angles are the same. Okay, equilateral. All sides and angles congruent. And our little symbol for congruent, of course, is just that little equal sign with the little wavy line over the top of it. All right, so we got equilateral. Now, if it's got 2 sides that are the same, okay, it is known as isosceles. That is 2 congruent sides. If it's got 2 congruent sides, that also means it'll have 2 congruent angles. Okay, 2 congruent sides, 2 congruent angles. And then if all 3 of them are different, okay, none of them are the same, it is known as scaling. All sides are different. Okay, so you got equilateral, isosceles, scaling. Those are your 3 choices when you do it by side. All right, let's come over here and talk about how can you classify a triangle by its angles. Do, do, diddle, do, 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 do. Guess what? The angles, where you classify them by angles, it's the same as your normal angle choices, basically. Okay, so you've got acute triangles, you've got right triangles, and you have obtuse triangles. So if you'll remember from previous lessons, or maybe even from previous years, acute means that all angles, okay, all of them, all are less than 90 degrees. Okay, so that means like all of the angles. So like in an equilateral triangle, they're all going to be 60. So there's going to be 60, 60, 60. Okay, so it would be an acute equilateral triangle or an equilateral acute triangle. So those 2 are going to go together a lot of the times. Okay, acute, equilateral. All the angles have to be less than 90 degrees for it to be acute. In a right triangle, okay, you got to have one 90-degree angle exactly. Okay, so at some point in the triangle, it's going to look something like this, and you're going to have that little square in the corner like that. Okay, so anytime you got that little square in the corner, of course that means it's a right angle. It's going to be 90 degrees right there. Obtuse also have to have one angle over 90 degrees. Okay, so they're going to kind of look something like this. Okay, I didn't draw a picture of an acute one, but we can draw a picture of an acute one. All right, so acute ones will kind of look like that. And if it was equilateral, that would be a 60, 60, 60. Obtuse, maybe this one right here is 120, and then you've got 2 smaller ones there. So obtuse has to have one angle over 90. Rights have to have one angle over 90. Acute, all of them are going to be less than 90. All right, so we can have like a right isosceles, or a right scaling, or an obtuse, I don't know if we have the obtuse isosceles or not, but an obtuse scaling. Okay, so you're going to take one choice. When I say classify, when I tell you to classify the triangle, okay, you're going to pick one from here, and you're going to pick one from here. So you're going to have to classify by angles and sides. Pick one of each of those. All right, so now we're going to take one of these. We're going to solve one of these jokers. Okay, and you've seen this stuff before. Once we solve it, we're going to classify it. You ready? So let's say we've got this triangle in our picture. All right, now let's say up here we've got 7x plus 8. Down here, we got 4x plus 2. And over here, we got 3. It's going to write 4, but I said 3. 3x plus 5. Okay? Now the question is, do you know how much all these angles are supposed to add up to in a triangle? Do you know what the sum of a triangle is? Anybody? I know. Okay, the sum of any triangle equals 180 degrees. Okay, so if you didn't know that, you need to make sure you get that down right there. That is a gold nugget for today. Okay. Sum of any triangle is 180. So when you add these three up, okay, just like it was supplementary, right? Just like if it was supplementary, you're going to set it equal to 180 degrees. All right. So I got 7x plus 3x, that'd be 10. 10 plus 4, that's 14x for my like terms. Add up my constants. 8 plus 2 is 10. 10 plus 5 is 15 for my constants. So 14x for the like terms, 15 for the constants. And again, since it's a triangle, just like if it was supplementary, we're going to set that joker equal to 180. Let me grab my calculator now. Okay, so we're going to continue to go to the hundredths place, just like we've been doing. Okay, so make sure you got your calculator handy or your cell phone handy, whatever the case may be. Let's see if we solve this joker, what it's going to be. So we're going to subtract 15. Put your train tracks down if you want to. You're going to minus 15 from both sides. So then I got 14x equals, let's see, 180 minus 15, that's 165. All right, and then I'm going to divide there by 14. 14, let's see what 165 divided by 14 is. 165 divided by 14. And we're going to go to the nearest hundredths place. So let me slide that over so you can see it better. So that is going to be 11.79 because there's that 5 right there in the thousandths place. We're going to round that up to a 9. So 11.79. 11.79 hundredths per x. Okay, now, just as we have done previously with the complementaries and supplementaries, we're going to take it and stick it in these jokers right here and find out how big the angles are. And then once we find out how big the angles are, we can go back up and figure out if it's acute equilateral or right isosceles or whatever it might be. So here we go. Let me get a little bit smaller pen for this. Be right back. Okay, there we go. All right, so now we're going to do, let's start down here. 3 times 11.79 plus 5. And let's see what that's going to be. 3 times 11.79 plus 5. That's 40.37. Okay. So this one down here is 40.37. So that's an acute angle, okay, because that's less than 90. So that one's acute. Let's see what we do over here. So that's 4 times 11.79 plus 2. And let's see how big that angle is going to be. 4 times 11.79 times, 4 times 11.79 plus 2. All right, that's 49.16. That also is an acute angle. Okay, so at the moment we've got 2 acute angles. Let's see what this big one up here is. 7 times that plus 8. So 7 times 11.79 plus 8. Ooh, 90.53. It's almost a right angle, just a little bit bigger, 90.53. Okay. Now, we've got an acute angle, and then we've got an obtuse angle. So this one's actually bigger than 90. So to classify it to be obtuse, it only has to have one angle over 90, and this angle is over 90. So this one would be obtuse. Okay, and let's see, are any of these the same? 40.37, 49.16, 90. Since none of those are the same, okay, all of them are different, that means it is going to be scaling. So that one is obtuse and scaling. Obtuse and scaling, because they're all different. They're scaling. We got one obtuse angle, so obtuse and scaling for that one. All right, so let's do another one real fast. Stick one down here. I'll try my best to see what we do here. All right. So let's say we've got 6x plus 4, 3x plus 2, and another 3x plus 2. All right. So again, all those added up together have a sum of 180, because the sum of any triangle, no matter how big or little it is, the three angles are going to add up to 180. So that's 3x, 6x, 12x for the like terms, 12x, and then we got 2, 4, 8 for our constants. We're going to set that equal to 180. All right, so of course we're going to subtract 8, and that's a 0 pair, so now I got 12x equals, that's 172. Then we're going to divide by 12 on both sides, and let's see what x actually ends up being. 172 divided by 12. 2 divide that by 12. All right, and if we go to the nearest hundredths place, since that's a 3 there, we don't need to round that up, so it's just going to be 14 and 33 hundredths. That's 14 and 33 hundredths. All right, let's see what we get over here. So we got to do 3 times that plus 2. So 3 times 14 and 33 hundredths plus 2. 44.99. 44.99. So that one's 44.99 degrees. That one's 44.99 degrees, because both of those are the same. So that one and that one are the same. Let's do 6 times 14.33. 6 times 14.33 plus 4. 89.98. 89.98. Okay. In reality, they'd probably say that was a 90-degree angle and those were 45. So they'd probably say 90, 45, 45. The reason it's not is because we did a little bit of rounding. So since that is so close to 90, I am going to go ahead and say that that is a right triangle. And then since we've got 2 of these that are the same, okay, 2 sides that are the same, 2 angles are the same, that would be right and isosceles. Okay, so that's how you classify that one. Right and isosceles. Alright, So, 1, 2, 3, diddle it. We got 3 sides, 3 angles. The 3 angles in any triangle have got to add up to a sum of 180, just like if they were supplementary. Okay, all 3 of these add up to 180. Same stuff we've previously done. And then when you classify it, make sure you go pick one from this, okay? Either it's equilateral, isosceles, and scalene. That's how you do it by sides. And then acute, right, or obtuse, when you do it by angles, you got to pick one from this crowd, and you got to pick one from this crowd. So you're going to have 2 answers total, okay, when you classify it. One by side, one by angle. All right, hope that does it for you for today. Until next time, ciao for now, baby. If you know more crazy songs got playing in the background, you can send me that too. Diddle-diddle it.